on LinkedIn and YouTube as we
Perfect.
speak.
Hi, everybody. We are just getting all the logistics set up as we speak. So give us a couple minutes and then we'll start the show. I think it's spotlighting you right now, by the way, Carly. Just FYI.
Yes, let me. There we are.
Oh, okay. It didn't necessarily need to be me either, but all right, perfect. Well, hi, everybody. We are currently setting up our restream to LinkedIn and also to YouTube. So just give a couple minutes for us to start the show. But if you want to chime in on the Q&A or on the chat panel, definitely say hi. My name is Denny. I'm with Databricks and I'm based out of Seattle. Scott, why don't you say hi?
Hey, everybody. My name is Scott Haynes. I'm out of California. I work at Nike, and I've been working in the Spark ecosystem for about 8 years. Thanks, everybody.
Perfect. Martin, you're next.
Hey, what's up? I'm Martin. I'm based in Berlin, actually. I'm working at Databricks, and I'm leading the efforts on Spark Connect from Databricks side. And I'm happy to be here and talk more about Spark Connect.
Perfect. And for those of you wondering, yes, Matej will join us as a special guest. He will be joining us in, I believe, in the next 20 to 25 minutes, but we're still confirming his schedule. He's got a very busy schedule, but he will be joining us very soon. Meanwhile, Carly, she hasn't introduced herself yet, but I'll let her do it when we kick off the show. But she's currently just setting us up on YouTube and LinkedIn, which is why there's a bunch of little logistics that we have to sort of nail down. So, but yeah, that's the current context for today. And just in case you're all wondering, yes, this is about Spark Connect. So just in case you're wondering which session you're actually attending today, that's the one you're here. Okay, perfect. Looks like we are live on LinkedIn now. Excellent. So for the LinkedIn folks, I'm going to go ahead and say hi to y'all too as well. Give me 1 second. All right. All right, to the folks on LinkedIn, session you're actually attending today. Oh, sorry. So the folks on LinkedIn, we are live, and folks on YouTube, we are live as well. So yeah, Carly, why don't you take it away?
Awesome. Hello, everyone. Welcome to today's session. Use Spark from anywhere, a Spark client in Python powered by Spark Connect. I am Carly Akerley with the Linux Foundation. I work in the marketing and communications department and assist open source projects with all of their marketing needs. We have a very exciting session today, but first I wanted to guide everyone and just remind that tomorrow, May 25th at 9 a.m., there is a Delta Lake Discussions with Denny Lee session. The D3L2, I will drop that link to register. It's going to be a great session discussing Rust, Ballista, Ray, SQL, Data Fusion with Andy Grove. So if you're interested in attending that, feel free to RSVP. And without further ado, I will pass it over to Denny.
Perfect. Carly, thank you very much. And so saying that, I wanted to do a quick introductions. My name is Denny Lee. I am a developer advocate here at Databricks. You're here to listen to Spark Connect. I wanted to let Scott say hi. He will be joining the panel that we have with Matej Zaharia, which he needs no introduction. He'll be joining us in the next 20 minutes or so. So Scott, why don't you go ahead and say hi before we switch to Martin.
Cool. So my name is Scott Haynes. I've been in the Spark community now for about 8 years. All the way from the early days of like Spark 1.6 and like D streams, working primarily in streaming systems, very protobuf heavy. So now we're talking about Spark Connect, which also is protobuf heavy. We're going to go into some other gRPC stuff with Martin. So I'll let Martin take the show and I'll come back in at the end for the panel discussion.
Thanks very much, Scott. Martin, it's all you now.
Hi, awesome. So hi, I'm Martin. I'm based in Berlin. I'm from Databricks. I'm the tech lead currently working on Spark Connect. And my background open source actually starts with Impala, like quite some time ago. And like started working on Spark Connect about a year ago. And I want to give you more background on this. So I will share my screen here in just 1 second. All right. Okay, so Spark Connect. I just need to move this around a little bit. 1 second. Okay, so Spark Connect in Apache 3.4 and beyond. All right, so about a year ago, and now it's really roughly about a year ago, we brought this Spark improvement process proposal to the vote, which was about like introducing this new Spark Connect project, which is like defining an interface, a client-server interface for Apache Spark. And in this talk, I want to basically bring you up to speed on like why again, like why did we motivate on doing so? Like why did we believe that this is necessary and where we are at this point in time? So when we're looking at Spark today, in many cases, Spark is very much associated, with data centers and large clusters. But over time, we've built tens to hundreds of different apps, and like we have thousands of users running Spark. And but that's all like when we're saying like applications and Spark, it's always like together. Like there's never like I have an application running that uses Spark. It's like always like intermingled. And the reason for this is if you zoom in into this architecture, what you see is that when you're using Spark, in many cases, the application logic of the way of how you're using Spark is actually intertwined directly with Spark's monolith driver. This means if I'm submitting a Spark job, it's not running locally, it's not running on dedicated, no, but basically running together with the Spark driver, and it's very much intertwined. However, what we've seen over the last couple of years is that these new data applications don't live in data centers anymore. They don't just live in data centers anymore. Like we see that we have this evolution, like Spark was really successful with this notebook interface, the ability of like having this interactive feedback loop. But now we have more and more, mission critical workloads. We want to see like, hey, like I want to design, develop, and integrate those from my IDEs. This is the way that I operate. How do I test this like against the cluster and so on? I want to be able to use Spark, not just like within Spark as an ETL system or like a notebook interface, but I want to be able to call Spark from anywhere. I want to use Go, I want to use Rust, I want to use all the new languages that are there to build my services. And then the question is like, what about edge devices? Today, like we connect to Spark, from laptops, from like servers. But what if I want to run an IoT device somewhere that wants to leverage the power of the Apache Spark ecosystem to essentially like use data, use machine learning, use AI and all of this? Like, how do I do this? So when we're talking about embedding Spark in applications, what we're seeing is that there are certain challenges around the developer experience. So when I'm basically building an application that isn't co-deployed with Spark itself, what happens is that I basically can only use SQL. And I mean, SQL is awesome, don't get me wrong, like it's very powerful, it's been there, there's lots of development going on. But it's not, what we're always used to, like Spark has the dataset data frame interface, it's very powerful as well, but if I want to use this from a notebook or in an IDE, I have to be very close to the wrapper, and the wrapper has to be very close to Spark to be effective. If I want to use, other programming languages like Go or Rust, I'm basically in a weird situation because if there is no JVM interop, I don't really have a way to talk to Spark without using SQL. So there's no good way really to interface there. And then there are a bunch of like other multi-tenancy operational issues. For example, my favorite one is like dependency conflicts, So for example, like because of the Hadoop 2 dependencies, like Spark has been packaging for a long time a very, very ancient version of Guava. And I always make the joke that, this Guava version is older than my oldest daughter. And, like, it's just to give you an idea, my oldest daughter is 12, so just to get an idea. So this is really this kind of like challenge that we see, because now all of these dependencies of Spark become like intermingled with your application. You have to figure out like, how do I shade my applications properly? How do I do this? And like, it's this constant conflict. Spark is upgrading, you try to upgrade, like what you need to change. It's kind of weird. Debuggability, like how do you do like step through debugging from your IDE, from the environment that you're used to? Like, how do you do this? How do you decouple the errors of your client application from the errors of Spark? So good one for this is, for example, out of memory exceptions. If you're collecting large result sets in the client today, what happens is you're creating essentially an exception on the driver and you're bringing down more or less the whole cluster. And like, how do you deal with this? So when we thought about this, we said, okay, like we need to figure out how to build an interface for Spark that allows us to basically surface or basically satisfy all of these client applications in the same way, and at the same time still leverage the full power of the ecosystem of Apache Spark. And the way that we wanted to do this is using is what we proposed as Spark Connect. So how did we get started? When we started looking at like what would be a good interface for Spark, we actually realized that, you know, the most powerful, most used interface of Spark is actually the data frame API. And like, what is the common denominator of the data frame API is that it expresses the intent of what we want to do. The biggest difference in today's world is that many of the operations in the data frame API are actually eagerly executed. Whereas like what we see is that what is in our belief is that we're actually looking for like a lazy evaluation of the model. So what we said is, okay, when we're looking at the data frame API, and for example, in this case, we see spark.read.table, select, extract something, write something somewhere, like this is the intent of the application. What we're doing now is we're taking this intent and translating this into a common representation, what we call kind of a logical plan. But it's not the kind of logical plan of the, you know, of Catalyst, for example, but it's like one level higher. Again, it's only there to express the intent of the operation so that we're able to say, I want to read a table. I don't care if this table is a particular Parquet table, if it's a Delta table, if it's an ORC table, that's not necessary. It's really just, there is something that is most likely going to be a table or something, and I just call it this. And then we're taking this logical parse plan, and we're sending it over the wire using gRPC encoded as protobuf messages, and then it's received on the Spark server, translated into the Catalyst logical plans, and then executed exactly the same way as you do any other Spark operation today. This means that all of the Spark ecosystem, the data sources, the plugins, all of this becomes automatically available to you if it's available using the data frame API. And once the queries are executed, the results are streamed back using gRPC and Arrow again, back to the client, and you can consume it from there, you know, in a language agnostic way. And like that's one of the key parts is that the representation of the logical plans that we have in our protobuf messages is completely language agnostic, and you can basically build clients in any other language. So what does this mean? So what we get is the power of Spark everywhere in a thin client. So I can use Spark Connect and Spark for that matter using PyCharm, VS Code, Jupyter from anywhere. I can run my Jupyter Labs on my laptop. I can run Jupyter in a gateway somewhere. I can use PyCharm and so on. I personally built some prototypes for Spark Connect in Go, Rust, Ruby, and PHP, you know, just to see, can I do it? You know, like what does it take to do this? You know, like what do I need to do? I basically need to be able to generate protobufs. I need to be able to call HTTP2 and gRPC, and I need Arrow. And that's about it. Like, as long as I have these things, you know, like I basically can get started. And then like all of a sudden, you know, once I have these kind of like fundamental pieces, all of a sudden I can integrate Spark into not just my expensive and like powerful laptop, but I can do this in the same way like on cheap IoT devices, you know, because again, like all it needs is a very small, very thin layer of like gRPC and you know, like protobufs to be able to call Spark and like essentially really leverage the power of the Spark ecosystem. And at the same time, you know, by this decoupling of my client application from the server, what I get is I get a bunch of benefits that I want to call out here. For example, now if I get an out of memory exception because I'm collecting too much data, the out of memory exception is actually happening on the client side. It's no longer bringing down the driver. It's still a failure, but it's no longer affecting the whole system in the same way. If I have dependencies that I'm using in my client, I'm no longer interfering with these dependencies with Spark itself. So my compilation class path is no longer the full transitive class path of Spark, but it's basically only what I need from the client API. And we designed the protocol in a way that gives you the ability to continuously upgrade Spark, and you can continue using your old clients. And we want to really like stress that it's really important for us in the community to make sure that the clients are backwards compatible. So this means if you can continue using the Apache 3.4 client, and you can continue using it for the next version of Spark and the next version of Spark, because we want to make sure that this is the stable interface that you're calling. And it's not like, oh, but what happens if I'm upgrading from Scala 2.11 to 2.12 and Python 3.7 to 10 and so on. But it's really that we're doing this contract on the protobuf area, which makes it much easier to upgrade the clients and the servers, and you don't have to upgrade them in lockstep. So this gives, like, if you have like hundreds of applications deployed throughout your users, companies, and ecosystem, you don't have to upgrade all of these clients together with Spark at the same time, but you can say, okay, I can upgrade Spark, I can see what's going on, and then like you can upgrade the clients to benefit from the new functionality that is implemented in these clients. All right, but enough of the introduction here. So what I really want to show you is like, how does Spark Connect in action look like, released with Spark 3.4 about, roughly about a month and a half ago. So at the end of the day, like what we really strive for is that there's no conceptual difference between, let's say, if you're using Python, really using PySpark and PySpark in Spark Connect. So today, when you're creating a Spark session, you're calling Spark session, a builder, a bunch of options, get or create, and then you get a Spark session. When you're using Spark Connect, like at the end of the day, the only thing that we added to the Spark session builder is this new option called remote, which gives you the ability to specify where do you want to connect. So basically says, here's a URL that points to an endpoint, and you can pass a bunch of parameters that allows you to connect to this endpoint. And this endpoint really is more or less really just an HTTP to gRPC endpoint. And then you can get or create. If you really don't want to change your code and just take your existing code and run it against like Spark Connect, all you need to do is export the Spark_remote environment variable, point to the Spark Connect endpoint, and then simply create the Spark session as you would have done in any other way. And now you can simply connect to Spark using Spark Connect from your laptop, from your whatever local machine to your cluster, and you can just use it if it started. So how to get started is very, very easy today in Spark 3.4. The Spark Connect service is not started by default. So you have to configure PySpark or Spark service essentially to load the Spark Connect plugin, which is a driver plugin that gets started as part of Spark. And like if this is done, like the Spark Connect service is started together with Spark. And you can connect, for example, from a separate shell by simply pointing to //localhost. And then basically your PySpark session will automatically connect to this locally running Spark Connect service. If your Spark Connect service is running on a cluster behind an Envoy proxy somewhere, like you can just connect to it and it will just work. You know, like, but so we started this project about a year ago, and, you know, like 1 year is not enough to rewrite a database, as we learned in many cases, you know, like, but so what is supported today, and like, where are we today in the world? So what is working with Spark 3.4 is essentially that we covered, I would say, 95% of the Python data frame API. So of all of the things that are you can currently do using PySpark, 95% you can continue on doing. The only thing that is missing in Spark 3.4 that will be there in the next Spark release is parts of the Panelist API that you can use Panelist on Spark essentially. But, you know, like this is like if you're checking out like Spark Master today, you can already use it. So, you know, like it is very much in progress. On the Scala side, we have the support for the untyped dataset API, and like currently in progress is the work for the typed dataset interface, and essentially the work for Scala UDFs as well. However, like there's one question, like this sounds all amazing, but, you know, like there's always this bad, like what does not work? And like we had this like very long discussion about like, hey, what is important to us? And like what we said, hey, so like there's this RDD thing, you know, like, and we're looking at this and saying like, what do we do with RDDs? And for us, it was a very clear simplification, because we're saying today we have 3 APIs to essentially interface with Spark and do data manipulation. So what we are saying is, okay, like we are simplifying this from 3 APIs to deal with data, RDDs, dataset, and data frames. We're essentially moving to 2, you know, the dataset and data frame APIs. And why? Because those are the declarative APIs. Those are the APIs that are important for us because they allow us to declaratively specify what we want to do and then leverage the power of Spark, the analyzer, and the optimizer to really execute these operations to get the best possible performance. But this doesn't mean that we're never going to do RDDs. So RDDs are still here to remain because there are a bunch of algorithms, there's legacy code, legacy applications, there's a lot of things that are implemented in RDDs, and I'm going to give you an outlook of like what you can do to work around this. So if you want to adopt Spark Connect in your applications, like there are a couple of things to be aware of. Number one is that the Spark context as the application singleton is not directly available in the client. And why is this the case? Because, you know, the Spark context is the application singleton. It's really something that is like very much tied to the lifeline of the driver itself. So we said, okay, this doesn't really belong on the client. We believe this is a server-side thing. And right now we're looking for a lot of feedback and understanding, like, hey, is there really something that we need to expose from the Spark context, or should we just like leave it out there and say like, hey, like everything that you have in a Spark session, that's good enough. The other part is that, obviously, since the client is now fully separated from the driver, we no longer have direct access to the driver JVM. There are a bunch of cases. If you look at PySpark, for example, which is in most cases a wrapper around the JVM object, like you could essentially access the driver JVM, instantiate Java classes and objects, deal with them, and from Python, like this is no longer possible. The Spark Connect API is fully language agnostic, so the Python client is implemented fully in Python, and the Scala client is like fully separated from the driver JVM, and like the Go client would be fully separated as well. So this is really important to us. And if you have RDD usage in your client applications, like you have to figure out a way, how can we most easily move them to the data frame API? So, but what does this buy me? And here's like my favorite example for this is this kind of like high fidelity development. Like at the heart, I'm a very big database nerd. I like to work with databases and like systems. Like I like development and testing. Like I write my unit tests. But like of course I can write as many unit tests as I want, but I will still make bugs because I'm human. So, but what is the way for me if I'm basically writing an ETL pipeline, if I'm dealing with data? How do I essentially get this kind of like high fidelity development loop, like this fast interactive loop? So typically what folks do is that they run a local PySpark, load some data sets, and then test it and verify this, and then say, okay, yes, this works now. Then but how do I do integration testing? How do I connect to staging? Like today I have to basically submit my job to a staging system, like wait for it to come back, maybe use Livy, figure out like how does all of this work? And what I get with Spark Connect really here is that I can write a very, very simple Python script, for example, that based on an environment variable allows me to connect to like two different endpoints. I can connect to my local Spark Connect endpoint. I can connect potentially to like whatever cloud staging environment that I have. Or if I have nothing specified, I will just like use whatever is the default currently set in my environment. And like using this like 10-ish lines of code, all of a sudden I gain a lot of flexibility in the way that I'm able to write my test fixtures, my application level fixtures that make it very, very easy to increase the fidelity of my application development, because I can write this once and then can run this from everywhere and connect to everywhere. Another example that I want to show here is that, with Spark Connect, what we get is the ability to essentially connect to different Spark clusters at the same time. Obviously in the times of, cloud storage, this is not necessarily the biggest use case, but there's still, there's benefits to understanding like, hey, what data is available here? What data is available in this cluster? If you have like cross-region consolidation, like there are a bunch of use cases where you say, I need one Python program that collects data from multiple endpoints, and like Spark Connect gives you the ability. This is really something that you cannot do with Spark today, because essentially like one Spark session is tied to one Python process that is interfacing with the JVM. And here's another example of like a very, very simple thing that I did. Like I wanted to, like I saw this on Hacker News. There was this library called Pickwalker that gives you this kind of like Tableau-like experience in a Jupyter notebook. And I was like, hey, this sounds awesome. Like, how do I test this? And now imagine like you want to do this like based on like some like real data. Like you want to do this in your environment. You say, okay, so I now need to deploy this maybe on my Jupyter gateway. I need to figure out like, where do I run this? How do I install this library? And all I need to do here is essentially pip install Jupyter Lab, pip install Pickwalker, and then simply use PySpark and like Spark Connect to connect to my remote endpoint, collect the data into Panelist data frame, and then use the library at my heart's content and like play with it and see like, does this work the way that I want? Is this the right thing for my use case? And this shows really how easy it becomes to build these kind of new applications. However, now I want to get back to this other piece, like we talked about RDDs a little bit. And this is what we call Spark server libraries. When we built Spark Connect, one of the key points was that we wanted to have extensibility and compatibility and stability, like for our applications. And one of the key parts here was that we wanted to make sure that the users of the Spark Connect protocol can leverage the extensibility in the same way. So when we look at the high-level pictures of like how Spark Connect looks like, it really that we have the client library that connects to the Spark Connect using the Spark Connect client data frame API to the Spark service. And in the middle, like we're taking like from the Spark Connect plans, we're translating them into the Catalyst plans. But what is if we need new APIs? Like what if we want to expose functionality to the client that isn't yet available as a data frame API? This is where we built essentially Spark Server libraries. And Spark Server libraries add protocol extensibility directly into Spark Connect. The key pieces in the Spark Connect protocol are essentially relations, commands, and expressions. Relations are things like reading from a table, a limit, a filter, a group by, very similar to conceptually, what you're doing on a data frame. Commands are things that invoke side effects. And expressions are things, things that you do with attributes. And in each of these points, we have an extension point that is represented as a Google protobuf any. So if you have any kind of application logic that you want to expose, you can register a plugin in Spark Connect that allows you to translate any custom proto message using a little bit of code into whatever you want. So if you want to expose an RDD into a data frame, you can simply write a relation plugin that allows you to call your RDD or your historical legacy application, your existing application code as a data frame. And this becomes really, really powerful. So let me give you a quick highlight like how this works. So if you want to build a new server library, you define your protocol extension, you do implement your Spark Connect plugin, you register it using Spark at startup, and then you can just use this from the client side in any language that you want. And that's the other key piece. If you've built your client, your server application, your server library, you can use this from Rust, from Go, from anywhere, as long as you know how to encode your proto message in there. So where did we use this already? So when we looked at Delta Lake, what we saw is that Delta Lake actually not only encapsulates data frame operations, but there are a bunch of other application code that lives around this. So what we wanted to do is essentially to say, okay, how do we use this in an efficient way? So we said, okay, we built the necessary extensions for commands and relations, and then ship a little bit of Python code to the client as well that allows us to consume the Delta APIs from the client directly on the server. And the cool part here is that the Scala client and the Python client, they share the same server implementation. So if the server is upgrading, getting features, you don't have to upgrade independently. My Scala client needs to upgrade my Python client and then the server. You upgrade the server, as long as the interface remains stable, you can continue using this. And this really shows that you can get the same kind of compatibility that Spark Connect provides as well. You can bring this to the clients with your custom extensions as well. And if you're now looking at the code, like how does the Delta code look like when you're using Spark Connect? There's no difference in the way that you're using it. Like the Python code that you have today for using Delta Lake is the same as that you would use for regular PySpark. And this is, again, like one of the key objectives that we had, is to make sure that when you're using Spark Connect, you're using it exactly the same way as you're using PySpark today, to make it really easy to test it out, work with the applications, and migrate to it. And with that, I'm reaching the end of my presentation, and I think we're open for questions, and I'm giving back to Danny here.
Thank you very much. Yeah, we actually have a lot of questions. So I think Matej's running a little bit late, but he'll be joining us very soon. I did confirm that. So, but let's go ahead and start asking a bunch of the questions that have popped up. So I'm going to be jumping around between, for anybody that's on YouTube and LinkedIn and Zoom, we're literally going to be rotating. So don't take it personally. I'm actually trying to go through all of them right now. So from the Zoom questions, or for starters, they were an anonymous person asked a question. They ran the Spark Connect -server.sh. That's to start the service, right? And to start the driver. When Spark Connect is when using Spark Connect for batch processing, is it necessary to start the Spark Connect service for each batch application?
I think the answer really depends here on how you deploy Spark today. So the way that the Spark Connect plugin is built is that it basically starts together with the driver. So if you are reusing the same cluster, like sequentially for each of your batch applications, then basically you start it once and then you submit your applications one after the other. If you're starting, so to say, a new cluster for every batch, then you basically have to start the Spark Connect service again for each batch, so to say.
Got it. Perfect. Thank you. And thank you, Matej. Thank you for joining us. So perfect. Well, good timing. Tay, you want to just go ahead and say hi to everybody, and then we're going to go continue some of the questions that were asked, and also I wanted to also pose some other questions about the creation of Spark Connect that are very applicable to you being here. So.
Sure. Yeah. Hi, everyone. Thanks for joining this. Yeah, I've been watching, on YouTube, and excited to chat with people.
Perfect. All right. Well, hey, I guess I'm going to actually pose the first question for you because Matej, if I recall correctly, you only have about 10 or 15 minutes anyways before you get a jet. So yeah, I'm just curious from your perspective, when you first, thought of Spark all those years ago, did you think that all of a sudden we'd be talking about getting Go clients and Rust clients to be talking to Spark?
Yeah, no, initially, we weren't thinking about that at all. But interestingly, we did see this pattern of people wanting to have, these operational applications outside Spark very early on. And, we started thinking about ways to do that. And, we ended up we did a lot with letting people write data engineering jobs and data science and so on. But there were all of these, one of the earliest users was someone who connected Spark to a web application for analyzing some data, basically their company let people analyze data about media and ads and stuff like that. And they had a really cool application, and they were asking, how can I, how should I run this? Should I run my web app on a Spark cluster? What should I do?
Got it. So this makes me segue a little bit to now to Scott. Scott, I wanted to pose the question for you because you and Martin and myself actually had some fun conversations related to protobuf in the first place. So yeah, why don't we start with that little context about how you were trying to basically utilize protobuf within the Spark context, and why, for example, I believe you're trying to play with the Rust clients yourself now, or this is the Go one. I actually forgot. Sorry.
Yeah, so it was the Go client, but I think kind of historically, when we were first starting off, I first started off with protobuf back in the days at Yahoo, and this is right around the time that Spark was starting to take off. We were on Apache Storm at the time, and we had protobuf because that was essentially the only way to have something that would work in a stream. Otherwise, it's just random data. So we ran into a lot of different issues with streaming Avro because of non-backwards compatibility or non-forwards compatibility issues. And so when I was working on Yahoo Games, we switched over to protobuf for all of our streaming data. And then we had protobuf as all of our streaming, everything for all our API servers for gaming SDKs and things like that. And it's been one of the only things that doesn't really break down over time. Fast forward, I joined Twilio, and we started working on a voice insights product that was taking, so essentially the eyes and ears of the whole entire company for, traversal across the networking stack. We needed something that we could rely on that wouldn't break down between releases, because we couldn't really go down for more than 5 minutes in terms of understanding how things were working and operating. So with that said, protobuf is really the only choice for that. And I have never been, bitten by it too much. There's end of wire exceptions and things if you do things wrong, but buff build and some of the other things make it a lot easier to not worry about breaking changes. But yeah, I could go on and on about protobuf as well, but I can kick it off over to Martin as well, so that I'm not hogging all the time.
Yeah, no, I think for us, I think my lessons learned from using protobuf was as well just kind of the compatibility. This turned out to be this one thing. Hey, we've seen this. You design a protocol, and the first thing is the question is always you're doing a code review is did you add a version? And I think protobuf just solved many of these things, these problems in a way that are very convenient and very important to us. And I think this makes it very convenient to figure out a way how we can test for compatibility. So there's a bunch of tooling around. Can we test against an existing release? Are my messages still compatible? And this is very important. It's not just the message itself, but as well the ability to say, okay, what's the supported tooling around this? And I in Impala, we've been working with Thrift a lot, and we always had this discussion, shouldn't we have picked protobuf back then? And it's I think now looking back, I think it's not so much about the difference of the format, but actually more the ecosystem and the evolving structure around this. And I think this is where we see protobuf to be really awesome and really usable in very different ways.
I think along those lines as well, I think it's interesting. So having native compatibility as well for protobuf in Spark now as of 3.4, outside of just Connect, I think it opens the doors to a lot of people who are, already have like gRPC systems. They're already passing protobuf back and forth. And like, in terms of like creating like analytic systems, a lot of times like the things that come up are, it's like, oh, we need this data, but we also need to run our business. So the data might slip. We just need to keep on running the business. But now it's, well, you can use the same data to also start running, more things on the analytics stack as well, without having to worry about like the back and forth of like, hey, this broke. Like there's like a lot of finger pointing a lot of times in like big companies that just happens, that happens. It's life. And with this, it's different, right? We added something new. You can opt into it. If you don't need it, don't opt into it. It will just, disappear nicely. It's an unknown field. Great. And I think those types of things are great for analytics. And I think for people who are kind of new to protobuf in general, it's really super powerful just for creating like reliable, analytic systems, reliable data systems in general.
Perfect. I did actually want to go ahead and call out, we had some interesting questions. So for example, one of the questions was, there's an ask about how can Spark Connect actually solve out of memory errors when you're working with multi-tenant environments? Like, isn't it possible for other clients or other queries to basically crash the driver because there are multiple clients trying, Spark Connect clients trying to connect to it? And this is open to anybody here now in this case.
Yeah, I mean, yeah. Sorry, go ahead, Martin.
I would just say theoretically, like it's definitely possible to do things that crash the driver, but it's a much smaller surface than isolating it from all the stuff in each of the client apps. Like there's all kinds of weird stuff in there that is not in Spark's control. And for the driver, because people are using it to have lots of concurrent connections for things like data warehousing and JDBC, it's already getting pretty robust. Hopefully it'll be quite robust to that.
Right. I mean, maybe just to add to that, I think one of the key things that we're doing in Spark Connect right now is we're trying to flush data as early as possible out from the driver to the client to basically push the pressure to the client. And I say it's more acceptable to crash the client than it is to crash the server. Like you don't want to basically, I mean, if I take the MySQL analogy, it's like you don't want to crash MySQL just because your JDBC connection died, And I think this is really like one of the core principles that we're relying on here.
No, that's awesome. That makes a ton of sense. So there's another anonymous person, but I thought that was applicable to all of us old fogies that are sitting here right now. Do we consider this as a replacement for Livy when it comes to like third-party ETL tools? Not trying to knock Livy, but it's old enough where I think I'm allowed to ask him the question now. So.
Yeah, I mean, I think Apache Livy is really cool. It really showed like the benefit of connecting apps to Spark in a very lightweight way. But it is based on basically sending over code in the form of text that you then execute, which is, it's hard to make it really secure or to like really control. Like, for example, if I don't want to let it do a join or like something like that, I have to look at this code and figure out what it's doing. So hopefully this can cover a lot of the use cases. It's obviously more work for the Spark engine than Livy was, but hopefully it can give some benefits. If you want to give people like an interactive, say notebook-like experience where they write arbitrary code, obviously Livy is good for that. But if you want just a few kind of specific things they can call, this is a structured way.
I think there's another interesting aspect here, which is, the cooperation between like Spark Connect and Livy. So Livy tries to solve many more things than like Spark Connect does. Spark Connect's goal was to achieve the separation of the client and the server, and not so much basically all of the management around Spark itself, because Spark is a very diverse ecosystem. Like everybody deploys Spark differently, manages Spark differently. So I think we explicitly did not want to solve all of these problems. So I think in an ideal world, like we find a way that the community contributes to Livy and basically builds, like this kind of HTTP2 proxying into Livy, that still allows Livy to basically connect and create the Spark context, like on the destination, but gives you a stable DNS endpoint to connect basically using Spark Connect to your cluster. So I don't think it's an either or. It's an evolution of the ecosystem to basically for Livy to find new kind of like usage essentially in the ecosystem.
Cool. So Scott, I'm going to direct this one to you. By the way, I just want to make sure that we're using Scott's and Matei's time really well before we go back to the more uber deep questions that, like, in terms of like the configurations. But Scott, I'm just curious from your perspective, what are some of the like use cases scenarios that you're going to be hitting off? But we already mentioned about the Go and protobuf, like from a high level, like from a deeper level. But I'm just curious, what are the use cases that you're trying to solve in that case by using Spark Connect in this case?
Yeah, so I think this was touched upon a little bit during Martin's presentation. So if you think about like connecting to multiple different backend clusters, for example, if you think about like data federation, I think that's something that's been on top of people's minds for a long time now. But it's I think it's bigger now with like hey, everything's a data mesh. We're trying to create data meshes and things like that. I think that Spark Connect seems like it's it would be a very applicable interface for creating a data mesh that actually has federation. If you think about connecting to Spark backend that's using Unity Catalog, for example, then you have the ability to actually say, hey, this can or cannot be run by this service principal. And now you have that way of having that centralized federation, but you also have the ability to kind of connect from anywhere as well. So I think that those use cases are going to be top of mind for a lot of people. And then for anything else where it's kind of typical APIs where it's I need to go and get some specific data. You think about like RSQL and all these other interfaces to be able to go and manipulate SQL data through like an API interface, be much easier to be able to say, okay, well here's our way of defining queries. And just being able to have the thin layer that is Spark Connect in the backend that's ensuring that the right people have the right access to the right data. I could see a lot more of those where it's replacing a lack of governance in like an API layer with something that's kind of more bound to the referrer who is the person who is asking for this data. I don't know if that's a good answer, but that's kind of where my head's at right now.
No, that's actually a great answer. So, okay, I did want to ask the question because this got popped up multiple times, so I really better ask this question now. What's the difference between Spark Connect and Databricks Connect? Because a lot of people were pinging me on these various channels about like, oh, which version of what you're supposed to do. So I'm just going to say it out loud. It's public preview as of Databricks DBR 13. Okay, so for those who want to use Databricks Connect, invariably, and of course, Spark Connect specifically to 3.4. Okay, or at least as of this conversation right now. So saying that, yeah, can one of you chime in just the difference between Databricks Connect and Spark Connect in that case, since these are two systems, different systems, but they're very related to each other.
Yeah, I think the easiest way to look at this is Spark Connect is the protocol that we use to power this. So Databricks Connect is not something proprietary built into Spark Connect, but it's really leveraging the power of Spark Connect, but like sprinkling, magic Databricks authentication, authorization, pixie dust on it. That makes it really easy to integrate into your application stack, into your IAM systems, into like all of your other Databricks products, So this is really like using the same powers that you have, but now, we want to use like OAuth. So we're going to ship OAuth support for DB Connect, as soon as the next release comes along. So there are a bunch of things that we just like add to make it easier to use like for Databricks customers. But if you want to use, you can still use the open source PySpark client to connect to Databricks using Spark Connect in the same way. And we really want to keep this open because that's the power of the ecosystems, like to be open and to allow everyone to connect. Like, and you don't have to use DB Connect to connect to Databricks, but it makes it just easier to integrate with the existing like Databricks specific tooling.
Yeah, I should add the current version of DB Connect is, built on Spark Connect. There was an old version we did a while ago that again kind of validated the need for something like this, but that was much hackier. And we said, hey, well, let's clean that up and like make that an official feature of the open source project. That one had a way of sending query plans and stuff. It didn't use protobufs. It wasn't as nice. It was really hard to maintain. So.
Perfect. Thank you very much. This is really helpful here. Okay, another set of questions I thought that was helpful for that people are asking right now. Sorry, we've got a lot, so I'm still trying to filter through all of them. It's the handling of like sorry, in terms of can we define quotas and priorities when it comes to like dealing with the multi-tenant cluster with multiple Spark Connect connections? Or I think we alluded to what the answer was already, but I did want to bring this question back up again, basically.
I think so. Today, I don't think that we have a great way of defining particular quotas for this. We're isolating the clients from each other. I think this is, where the more multi-user Spark becomes, the more there is an opportunity to add these kind of features that basically allow the specific quotas to be set on the individual Spark sessions and so on. So I think this is like going forward, this is like, it opens an avenue to actually do more in this area. So that's like in specific for like isolating individual quotas of Spark sessions within one Spark context.
Cool. No, this is perfect. So that answered a bunch of questions here. Let me go ahead and there is a Databricks specific question, but I figured again, this is being asked enough, so I figured we should answer this one now. People are wondering what's like the DBU cost structure for using Databricks Connect versus like using a standard notebook.
I think so. Today you can use Databricks Connect to connect to any interactive cluster. And so it's basically the cost structure of your interactive cluster is basically what's happening. So that's the purpose. Well, you're doing interactive connectivity. So you're connecting to something as an interactive cluster, can be shared cluster, can be an all-purpose cluster. And you can just use that. And that's basically how the cost is calculated for it. It's actually very easy. It's like interactive cluster, interactive usage. That's it.
Perfect. No, love it. I figured that we had to call it out anyways. Okay, yet another question, set of questions that people are finding pretty common, excuse me. People are wondering, can you Spark Connect in production? And it seems like providing you lots of benefits. What are we giving up? So that's a two-parter, I realize. But why don't we start with the first part, which is, can we use Spark Connect in production yet?
I can answer that. Yes. Cool, right?
Yeah, no, it's completely cool. Yeah. Now, mind you, Databricks Connect is technically still in public preview, but yeah, we wouldn't have put the code in 3.4 unless we felt that it was in decent enough shape for everybody. All right, now I guess the more complicated question is more the obviously these are great benefits. What are we giving up when we use Spark Connect instead of querying directly using the whether it's a Databricks notebook or you through the shell or anything else? Yeah, people are that's a pretty cool question, actually, I feel.
Mate, you want to go?
Yeah, I mean, I would say it's mostly like some of the older parts of Spark that we didn't want to support here, like RDD. So there'll be some older code that maybe doesn't work. There'll be some libraries. We're working with the community to try to update those libraries to work well with data frames and Spark Connect and Spark SQL. Those are all related because we think that's just a better interface to where like the engine can handle memory management, handle performance, and just make things more robust kind of on its own versus the RDD approach where like you hold a lot of that in custom code. So that's currently the kind of the line we do at like, hey, we're not going to run this stuff. And, we'll see how it goes, but I'm hoping that it stays that way and we can eventually make that stuff be more of a internal thing, but not something that most users have to care about and worry about.
I would like to add like my most favorite Stack Overflow example here of the things that we're giving up is like Spark context.parallelize. Like this has become such a ingrained thing in the Spark community that you find this everywhere because it gives, but it basically gives you something physical. Well, it basically gives you an RDD that has partitions and so on. Like in many cases where I've seen is this kind of like, I use Spark context parallelize 5, give me 5 partitions, and I use this as a physical means of like dealing with data. And I think this is really the anti-pattern in Spark Connect, because in Spark Connect, we want to move on this to the declarative approach of saying like, this is what I want to do with my data, not so much the how I want to like use my data. And I think this is, like every time we're saying like, hey, how do we migrate? How do we get people to use them? I'm saying like, hey, let's get rid of Spark context parallels, because this is, like this is, you find this, like search the internet and it's the first thing that pops up anywhere. So this is, I think, like some of this, another, like along the same lines, like, hey, like not trying to think about like the algorithm, but think about like what you want the result to look like, like the SQL approach to the data.
I was just going to also say that.
Oh, sorry. Let me. I apologize, Scott. I just wanted to give. Matej has to drop off now, so I wanted to just give him a graceful way to exit before we continue our conversations.
Yeah,
so Matej, I just want to say thank you very much for joining us.
Yep, got to run somewhere else, but yeah, see you folks later.
All right,
thank
you.
All right.
Scott, my apologies. Yeah, but
no worries at all.
Matej's schedule.
No, that's completely cool. Like for me, it's awesome to just be part of a conversation with Matej in it. So aside from that, what the other thing that kind of came up for that other question about like how do you handle quotas and how do you kind of clamp down on out of memory? How do you stop kind of thundering herd or anything else that could happen in like a multi-tenant environment? I think a little bit more about how like the data, the data frame API. You have statistics. If you think about Delta Lake, you have statistics. If you think about like, optimizing query plans with like adaptive query execution, you need statistics to understand how that stuff works. In the RDB world, you don't have the ability to say like, we understand how this application is going to behave. But with a data set like APIs, you have a way of saying this is how we believe the performance of this, procedure is going to behave. And so I think if, in leading towards, being able to, be cost effective in terms of quotas or being able to say like, we understand the estimated cost of running this specific operation, then it'd be a much better way of, being able to kind of, federate usage within like, a, scarce environment.
Oh, sorry, I muted myself. My apologies. Okay, perfect. Now we've only got about 3 or 4 minutes to answer the rest of the questions. So, but I did want to go ahead and at least try to bulk them together. There's a common theme or a question about how do you debug Spark Connect in that case? Like, how do you do step debugging, or how do you like understand the stack trace? Because now, like, it's like, are we literally going to send all the Spark driver wonderful messages that it can integrate and send them all directly to Spark Connect?
Right. I think so. The easiest way, like the first step in like when we think about debugging any Spark Connect application is really to say, okay, so imagine that instead of using Spark Connect, we're using a JDBC connection. Like what can I do? So basically, as soon as you execute a statement on a JDBC connection, this is basically where you hand off to the Spark Connect service and then it runs it there. But if you have a Python program in PyCharm, you can debug everything up till that. And the cool part, unfortunately, I don't have my video here with me handy, but like if you are pausing inside the execution, since every time you're doing an operation on the data frame, you're creating a new data frame, you can completely, introspect and manipulate like the data frame that you're currently pausing your debugger at, and this is a really powerful means because let's say you're having a debugging and transformation logic, you're pausing in a line between like 2 transformation steps. You look at the input data frame, you can df.count, df.sample, df.whatever, like you can df.show, like you can really live interact with this in your, IDE. And this is this kind of really powerful thing. So talking about error messages and stack trace, I'm not a huge fan of Java stack traces. I think I just come from like standard SIG-11s, and then attaching GDB and like trying to look at this. So, I mean, I'm not the best person, but I think this is again, like with the community, we're working on like identifying how can we make these more handleable. There's this awesome work currently going on in Spark on the error messages itself, like providing more useful error messages and avoiding showing like stack traces, because I mean, everybody that has ever looked at a Spark stack trace and that has like 150 lines and you're trying to find the beginning and the end of like where's actually the stuff that matters, and the usefulness can be, like kind of limited. So I think like we might have a better opportunity of not showing too many of these stack traces. So I think it's there's still some development going on in the Spark Connect development side to understand like, hey, how can we provide other information as well to the client? But the debugging is like more or less what I outlined.
Yeah, and I just want to add to exactly Martin's point. Like, definitely join us in this the Spark communities, right? Whether it's the dev alias or the user, anybody who's joined us, we're very, very active. Chime in here. There's already discussions even just this morning about what happens where the Rust clients and where the Go clients are going, whether we even put them in different repositories. This is a way for you to impact how we start, not just where do we put the code, but exactly to the question here. What type of error messages do we provide? We've been working actively for quite some time to try to make these simpler. And the reality is, even especially when we dive into working with Arrow and everything else, it's in some ways it's going to get more complicated. So we're trying our best to figure out how to simplify. So please chime in on these things to basically, help us out so we understand a little bit better. Now saying this, I think time's up for us. It's 5 minutes to the hour. So I wanted to thank Martin and Scott for their participation in this panel. Martin, again, I wanted to thank you very much for presenting. For all those who we were not able to answer the questions, again, I apologize for that. We stacked a little too much into this one session. So please join us on the Spark users alias distribution list. This is a great way to continue asking your questions so we can chime in there. Any call outs or action items that you want to call out, Martin, before we shifted it back to Carly and she can close us up?
I think the biggest wish that I have is more language diversity for Spark. So if you're feeling you want to contribute to the Go client development, the Rust client, PHP forward, all it takes, Ruby, I really encourage all of you to really push forward. I think this is really something that can change the face of Spark. So if you're having an interest in that, please contribute.
Yeah, and look for me. It's not related directly to Spark Connect. Oh, sorry. It is directly related to Spark Connect, but basically look for me to help with the Rust client. So just ping me anytime, because that's one that a bunch of us are really, really interested in going and taking to the next level. So yeah. Okay, well then that's it. Thank you very much, Carly. Anything we need to do to wrap up?
Excellent. There's just about a 10-second delay between the live stream on LinkedIn and YouTube. So I'm going to wait about 7 to 10 seconds until I end this webinar.
Perfect. Well then, everybody, thank you very much. Martin, Scott, again, thank you very much. Take care, y'all.
Thanks so much.
Hey, everyone.
Thanks,
Bye-bye.
Carly, again.
Thank you. Bye-bye.